Okay, class, our next topic is to find equivalent resistance of combination circuits. If you remember in our previous lectures, we covered series circuit and parallel circuit for combination of resistors. And in that lecture, we learned how to find the total resistance or equivalent resistance of series circuit or parallel circuit. Now we will discuss about finding equivalent resistance of combination circuit. Combination circuit means it's a combination of series and parallel components. As you can see in this circuit here, it looks a complicated one because it is a combination of series and parallel elements. Series and parallel resistors are connected in this circuit. Point A and B are the 2 points where you have to find the total resistance of this combination. So how to do that? Let's see. First of all, as I told you, whenever you have to find the total resistance, in this case, you have to find the total resistance at point A and B. So you should start from the opposite side of point A and B. So the opposite side would be here, where you see the 10 ohm resistor and 15 ohm resistor. These two resistors, you can clearly identify that they are in series. Okay, like here you can see these two are a series connection. So finding their total resistance is easy by simply adding them. So 25 ohm is the total of these two. Now after this point, you can see that this 25 ohm resistor is in parallel to 30 ohm. Why? Because you see the two ends of these two resistors are joining at this point, and the other two ends of the resistor are joining at this point. So one resistor you look as a slanting, but if you make it straight, it will be the same like a parallel combination. So in parallel, the both ends of the resistors are connected with each other. You can see here at these 2 points. So to solve the total of these two, you have to use this formula for parallel circuit. So after putting in the values of 30 and 25 ohm resistors, you can easily find the total resistance of these two. Remaining, you just have to do the maths and you can reach this conclusion 13.6. Now as you are finding the equivalent resistance of resistors in stages, you are working in stages. You are not working on the whole circuit as collectively, but you are working on small parts. So when you finish one small part, it's better you draw a new circuit so that now you look at the simplified form of the circuit. So now you have solved these two resistors 30 and 25. So now you draw another simplified circuit as seen here. So this is the result of the two parallel resistors which we just solved. Now again, we can clearly see that these two resistors are in series. Simply add them together and you find this circuit. So you are solving your circuit in stages, in steps. At the same time, you are simplifying your circuit diagram. So after solving these two, you end up only with two resistors and they are connected in parallel. So to the last step, use a parallel formula, do the maths, and you find the equivalent resistance as 10.4 ohms. So you started from here in this circuit, which was a complicated one, and you end up here. Okay, you simplified your circuit and you are just using two formulas. One is for parallel, one is for series, and you are able to find the total resistance, which is this one here, the final answer. Yes, it will come in exam, guys. If I saw a message in the chat, it will come in the exam. In some questions, you have to solve the circuit. Not exactly this problem, but it could be a similar one. We will discuss on the go. So this was example 5 to find a equivalent resistance of the circuit. There is one more example 6. Okay, same procedure. It is being explained here by, see, looks like an envelope shape. Okay, but these two resistors, 20 ohms and 20 ohms, you can draw them like this. Okay, this is a optional example. So if you want to solve this, you can solve this question yourself. So I have left this question for you to solve. One I have solved above. This one you can solve it yourself. So I have also given you the simplified circuit as below. It's very easy. Simply these two resistors are in parallel, solve them in parallel, find their total, and then you will find these two resistors in series, solve them in series. Their resultant will be in parallel with the last resistor, this one here. So then you solve them in parallel. So that's how you can find the total resistance. Okay, so I will stop the lecture here. This was all about finding the total resistance of a combination circuit. Any questions? I will open the question answer for